Welcome to Spring LIB.
So this question asks us to plot y versus t at x equals 0 for y equals 0.150 times cosine of 15.7x minus 50.3t. At x equals 0, this function becomes y equals 0.150 times cosine of negative 50.3t. And we can use the property that cosine of x equals cosine of negative x. So we can say that y equals 0.150 times cosine of 50.3t. So now we can plot this function here, and we'll put y on the vertical axis and t on the horizontal axis. So we can start with just plugging in values of t. We know that we can plug in t equals a 0 here, and that would be cosine of 0 is going to equal 1, and 1 times 0.150 equals 0.150. So y of t equals 0 equals 0.150. So we can make a point here, our first point here, and we can label this value as 0.150. Now we know how cosine looks. It's going to oscillate along the t-axis. And so we know it's going to come down to 0 at some point, and we'll put that here at this first tick mark. So what we have to figure out is what t value this is at. So we can look at the argument of the cosine function, which is 50.3t. And we know that cosine of this value equals 0 when this value is pi over 2. So cosine we'll just call it x for now, equals 0 when x equals pi over 2. So what we can do is set the argument of the cosine equal to pi over 2. So 50.3t equals pi over 2. And solving for t, we get t equals 1/2 times pi over 50.3. And so we can label this point here as 1/2 times pi over 50.3. Now we know it's going to hit this 0, and then it's going to go down to a minimum value down here. And this minimum value is going to be negative of our maximum value. So this value down here is going to be negative 0.150. And it's going to be when the cosine term equals negative 1. So negative 1 times 0.150. And we know that happens when the argument of the cosine equals pi instead of pi over 2. We're going to set that equal to pi. So now we can set 50.3t equal to pi to get t equals pi over 50.3. So now we can label that on our plot, pi over 50.3. Now we know cosine again is going to come back up and hit 0 when the argument of the cosine equals 3 pi over 2. So now we can go and set 50.3t equal to 3 pi over 2. And again, solving for t, we get t equals 3/2 times pi over 50.3. And again, we can label that on our plot. And then finally, we know it goes back up to the maximum value when the argument of the cosine equals 2 pi. And we find that that happens at t equals 2 times 50.3 under pi. And once again, we can label that on our plot. 2 times pi over 50.3. And now we can trace out our points, knowing the general shape of what cosine looks like. And so what we've done is we've plotted one period of the cosine function from the first peak to the second peak. So that's part A. Now we can look at part B. Part B is trying to find the period. So the period is the time between two peaks. And so what we can do is take the time of this peak and subtract it, and subtract from it the time at this peak. So the period is going to equal 2 times pi over 50.3 minus 0. And we find that the period equals just 2 pi over 50.3, and this is in seconds, which is equal to 0.125 seconds. And part C tells us to compare to example 16.2, and we find that this is exactly the same period. And looking at the function from example 16.2, it's actually the same function. So you can go back to example 16.2 and compare your answers.